installation of 3 RSUs.
Thank you very much. Okay, Mass. And Bueno, we're going to door closure. Okay. Mass, if you could go to the right aft shroud door and take care of the tether.
Oh, yeah.
Tether.
Can't forget about that, can we?
Video from Mike Massimino's helmet camera as he and Mike Good have completed the installation of the Pi harness and are moving on to close the minus V3 shroud doors. EVA Officer Tomas Gonzalez-Torres reporting to Flight Director Tony Sacacci that the crew members are an hour and a half behind the timeline at this point as they would move on to the battery replacement task.
We're clear now.
What's that?
We're clear now.
Yeah, I think it goes back to Mike out when the door is coming towards you. Cool. Yeah, we go. We're good.
And that radiator's crooked. Thanks. Tell me about it.
Everybody's a critic. Okay, I'm ready to come to my left and into the south scope for the door.
Anthony, if you can go get the left door.
I'll do that. Four and a quarter on 13, Drew. Good torque.
Copy, 4 1/4 on 13.
Okay, Megan, let's go up. I'll call your stop.
Coming up.
Massimino has engaged all of the bolts on the old battery module. The first 5 bolts on the new module securing it to the Bay 2 door have been engaged. This is the view from Mike Good's helmet camera as he uses that pistol grip tool to engage the remaining J bolts to secure that new battery module in place. Atlantis now 352 miles above the southern Indian Ocean. Payload bay camera view shows Mike Massimino in and out of the view at the bottom of the screen. He's
meet me on 2 regarding solar race low.
He's going to be removing the manipulator foot restraint handle from the MFR and handing it in the airlock to Mike Good. Good is inside the airlock already.
It was really great going out there with today for my first time. Big thanks to everybody on the ground. Incredible effort. Dan, you really saved us. Tomas, Christy, great effort. And everybody inside here taking care of us too. Really appreciate it. Like to echo what Mike said. Mike, it was a pleasure going out with you and honor on your first EVA. You did a great job. There's about 1 million people to thank for getting us ready for our shoes and batteries. The couple that come to mind though are Kevin Matthews and Mark Giroux helping us out and up at Goddard, along with Ed Rizak, making sure that I stayed on that platform they built for us, and Marion and 1,000 other people. So thanks very much.
Well, for Mass, you and for you, Colonel Good, Bueno, the service call on Hubble, those gyros are crucial, and Hubble's batteries were getting old. Batteries are included on this flight. You did a fantastic job, and when you're ready, com mode to hardline.
EV3 going to hardline. EV4 going to hardline.
Hey, John, while I've got you, I've got some great news to pass. Again, to your the whole team's diligent efforts, all the RSUs and the battery all passed good functional tests.
Thanks, Dex. That's fantastic news.
We could tell.
Control Houston.
I want to take some time and explain in more detail some of the ACS tasks, some of the ACS tools that we'll be using. I think this will help everyone understand the video that they'll be seeing later on. So I want to begin with, again, the summary of the ACS task is that the crew will have to remove 4 of the electronics cards that are inside of the instrument. And in order to do that, they'll have to remove a cover plate, which is similar to this. There are a total of 32 non-captive fasteners on this cover plate, the total of 36 that I've mentioned before includes 2 additional fasteners on either side of the card, and these will be used to install some guide studs, which will then be used to install some additional tools during the task. One thing, though, is that over this cover plate, of course, is a grid. So we need to remove that grid in order to just get access to that cover plate. What the crew is going to do is they're going to use this grid cutter. Each one of these legs has a bolt associated with it and also has a blade. As the crew drives the bolt, the blade will come down and then shear one of those legs on that grid. At the same time, it will also trap and control the grid so that we don't have a sharp edge hazard. So once this has been removed, then the crew will actually have the access to this black cover plate, and they can begin releasing all of the fasteners. Now, because of the visibility and the access to this work site, which is really tight up in the right-hand corner of the instrument, we are initially breaking the torque on all of the fasteners using a manual tool. This will ensure that when we come back with the power tool, that we don't strip out any of the heads of the fasteners. Once all of the fasteners have been released, the crew will be installing this item, which is the fastener capture plate for the ACS task. Now, this lines up with all of the holes on the black cover plate. You can see that there are numbers on all of these, and so there's a total of 32 fasteners that will be released. This cover plate is specifically designed so that the holes are large enough so that the bit from the drill can come in and release it. However, they're also small enough that once the fasteners are all released, they don't come floating out. So once everything is released, this cover plate will be attached to this black plate. Excuse me, the fastener capture plate will be attached to the cover plate. This whole thing will come off as one unit, and then the crew will have access to all of the cards. During the removal of the cover plate, depending on the location of the fasteners, the crew will have either better access or worse access. So some of them will be fully released, again, using the manual tool. And some of them will be released using this item, which is the mini power tool. This tool was specifically built for the STS and ACS tasks. It's a high RPM, a low torque power tool. It has an LED array on the tip that provides additional illumination to the work site. And then again, as I mentioned, it's a high RPM, but low torque. So now that all the fasteners have been released, then the crew has access to all 4 of the cards. And at this point, the crew will then use this item, which is the card extraction tool. Their indexes, you can see that there's a spot for each of the 4 cards, and by rotating this lever, the crew will be able to move this jaw from one position to the next. These are the jaws that the crew will use to clamp on to the card, and then by driving this additional bolt, it will actually extend some elevator blocks that will pull the card out from the current location where it's at. This will be repeated, of course, for all 4 of the cards, and as the cards come out, they will each be going into an enclosure to control them. EVA 3 again will begin by having the crew egress from the airlock. Drew Foistel will once again be on the robotic arm, and John Grunsfeld will be the free-floating crew member.